Excess Material Exchange is a young technology company that finds new high-value reuse options for materials and waste products of businesses. In addition, it provides companies with valuable data about the potential positive impact of environmental and financial performances of excess material flows. So let's hear how our dating site for material works. Our next guest is Maayke Aimee Damen, founder at Excess Materials Exchange. Welcome, Maayke.
Hi, thank you so much. How is everything going? Let me share.
Everything is fine. Thank you.
Share my screen in the meantime.
Yeah, sure.
Okay. How does this work?
Absolutely, it does.
Great. So welcome everyone. I hope you've been having a great day. My name is Maayke and I am the founder of the Excess Materials Exchange. And before I tell you what it is, I have some questions that you can answer in your head. Oh, let me see. Oh. So the first question is, what percentage of the products that we buy end up as waste within 6 months? What do you think it is?
You said that we have to answer in our mind.
Think in your head. Yeah, don't worry. It's actually 99%. It's a lot more than I initially thought. And then of that, what percentage of the material value is lost after a single use? What do you think? Again, just think in your head. The answer is actually 95%. And the cups you see in the back are a great example of that. We use them once, we drink out of them maybe 5 minutes, and then we throw them away. And all the value that's been put into it and the energy that's been put into it to make it is lost because nothing is done with it. So why should we care about materials if we talk about a circular economy? Well, we see that resource extraction is on the rise and is projected to increase even further, as you can see on this graph. And at the same time, the complexity of the products that we put on the market is becoming increasingly complex. So initially we had some products with iron and some calcium, and then it increases to the materials that we have now in our computers, in our solar panels, with names like indium and neodymium. So we see that is becoming complexer as well. But then if we look at the forecast of how much of these materials that we still have left in the earth, so not what we have mined, but what we have left in the earth based upon the forecast on technologies to extract it and known reserves, we see that there isn't too much left. So they're getting scarce. We mine a lot of them, whereas the demand is increasing and the complexity of the products is increasing too. So where do we get it from? I mean, we're in the EU. I'm calling in from Amsterdam. A lot is coming from other countries outside of Europe, a lot from China. There's a lot coming from Russia as well. And with the current situation, the economic and political tension is rising. So being dependent on import is a risky choice. Whereas if we look at the recycling rates of these materials, they're very, very low. So we've mined a lot. It's all in our built environment. We're very dependent on other countries, but in the meantime, we're not doing much with it. And we see that the worldwide waste mountain is actually expected to grow with 70% in 2050. So this problem is only getting worse. So then what is the dream? I mean, the dream is a 100% global circular economy in which resources can continuously cycle through different sectors without having a negative environmental impact, because people forget that, but it's a very important aspect of it. But at the moment, the world is only 8.6% circular, and we don't really have the exact tools to bridge that gap. We have lots of ideas, there's a lot of commissions, there's a lot of talking, but the actual tools are missing. So what would we need for that? Well, if we, on a large scale, want to exchange materials, we need information about the quality of the materials. Like, is the window that I would want to have as a secondary window, does that fulfill the same requirements? Or is it 30 years old and it doesn't fulfill the requirements? Is the time when I'm building the same time as when it's released? For example, if we're talking about building elements. If we talk about quantity, I have 30 doors available, but I can only sell 10. So what am I going to do with the other 20? And what is the location? We don't necessarily want to make matches between, in my case, Amsterdam and New Zealand. That is not the most optimal thing. So at the moment, there isn't really anything that helps us answer these questions in a structural manner. So that's what we do with the excess materials exchange. We provide a platform where companies can buy and sell any type of excess materials. And we say it functions like a dating site. So we match this supply and this demand. And at the same time, we match materials with our highest value reuse option. And this means a positive financial business case or reduced cost. And we pay attention to the environmental impact of the product. So how do we do that? Well, first of all, we start by giving all the materials around us and the products around us an identity. Like the ingredient list on food products, we want the same in detail of the products and materials around us. Then we add intelligence in the form of human intelligence, but also in the form of AI, a zero knowledge proof protocol, blockchain. And then we look for integration, because very often the most or the highest value match is found between different sectors, not in the same sector. And I'm going to give you an example of that, but I'm going to start with identity. So what is this identity? Well, we give these materials and products an identity in the form of a resources passport. And this is what it looks like on our platform. It basically tells you, like, what is it? What does it look like? Where is it? Who's the seller or the buyer, potential buyer that's wanting to buy secondary materials? What is the functionality of it? How is it put together? Where is it coming from? What processes has it undergone? And who is the actual owner? Not just the location where it is, but who owns it, from who do I buy it? Can we trace it? Financial value. So this is an idea of the identity that we give. And we attach this identity in the form of QR codes or RFID chips to the actual physical product. It depends a bit on the product, how we do it. Then we add intelligence. So we work, or we think in networks, and that is how we look for the most optimal matches. The searchability this way is biggest. And here you can see we start with a plastic bottle, a PET bottle. And if we look at components, one of the components of that is polyethylene. And that also happens to be a component of carpets, which is interesting because once you're done with drinking from the plastic bottle, it can actually be used as a component in the carpet industry. And this doesn't only hold true for this match, but it can be done in many other ways. So this is how we add the intelligence, because if you look for matches, AI does it much quicker and much better than humans does, because you have to take into account so many things as quality, quantity, timing, location, and, for example, components, but also color, etc. And then we look at integration. So as I said, the most valuable matches are very often made between sectors, but they don't really talk to each other. They think they're just, the aerospace industry is doing something completely different than the paint industry. So they don't look at their own materials, or if they can exchange them. An example is orange peels, as you can see here. So we've looked at circular matches, and you can, for example, with orange peels, turn them into an ingredient for soap from the orange outer layer. You can use the white inner layer as fibers for animal feed, or you can use them as biogas. And the most optimal match actually combines number 1 and 2. So there is a process where you can extract limonene and the fibers, and this results in a 50% reduction in cost and a 99% reduction in carbon emissions, which is incredible. Then another match that we made is railway tracks. They're everywhere in Europe. What do we do with it? Right now, very often they're sold for a scrap metal price and sent back to China to be melted. but they can still be used as tracks in another functionality or lower functional requirements. As a support beam in buildings, this is actually done in a couple locations in the Netherlands, and as quay walls, also done a lot in the Netherlands. And the most optimal match here, so financially and environmentally, is using them as support beams. The financial value at the end of the life of this product increases 4 times, and the carbon emissions are reduced by almost 80%. So what we've done to test this is work with the logos, or with the companies of whose logos you see here on the right of the screen. Maybe you know Schiphol, the airport in Amsterdam, DSM, a big chemical company, so Dexo, Philips, you might know, Arendt is a furniture company, Heembouw is a construction company, and we looked with them at 17 material streams and investigated if we could actually find a higher value destination for these streams than where they were currently going. And the results were much better than we initially expected. I mean, we thought there would be good results, but they were even better, because we created a potential of 64 million euro in financial value just for these 17 streams for these 10 companies by finding another destination. We saved enough energy to light the street lights of Paris for 5 years. We saved enough carbon emissions of all the inhabitants of Amsterdam in the car driving to Milan. And we saved enough water to fill 860 Olympic-sized swimming pools. So the results are amazing, and we hope you join us in this revolution to create a circular economy. Thank you.
Thank you, Maayke. It was really, really interesting. I just want you to focus for a second more about the results of your exchange, because from here it seems, you know, it seems like this is exactly what we need to implement circular economy. So, the demand is what you were expecting? It's growing fast. Tell us something more.
Yeah, so people are loving this idea. I think there's no lack of enthusiasm. We do see that in times of crisis. We are not a business driver. Like, what we do is we work with an excess material. So it's already written off the books. And in order to start exchanging materials on a large scale, a lot of things need to happen within companies. So we do a lot of consultancy as well. Because if you give an identity to the material, people are already like, oh, but maybe if we design it differently, like if we don't glue the parts together, but screw them together, so we have 2 separate components, the value increases. So there's lots of things that need to start changing within the organizations that we work with in order to fully reap the benefits of this. So no lack of enthusiasm. Implementing this is a different story. And that's also the reason we started this. We know there are problems galore, like really no lack of problems. But if we just keep talking about this, we're not going to solve it. We need to start working with them, trying, like, if we go left, what happens then if we go right? And so we create very risk-free environments for these companies to tinker in, basically.